Welcome to this edition of our podcast. I'm here with Adam Dendrinos. Adam Dendrinos is the segment lead for Electrification at AVL. I'm Stephan Tarnutzer. I'm responsible for AVL Mobility Technologies in the US. And I'm happy to talk to Adam today, super knowledgeable guy. And we're going to talk about electrification. So vehicles, batteries, inverters, BMS, e-motors, all sorts of things. So we keep it very wide. But Adam is very much an expert in many of these areas and certainly in batteries. So maybe we'll start out with batteries, Adam. Cell, module, or packs being the most critical design or technology element of a battery, or are there other pieces to it?
Well, I think all of those are very important aspects. Obviously, the most critical is the cell, just because that's where there's innovation. That's where there's a lot of focus on energy density and gravimetric density. That being said, though, new things are coming into the market with cell to pack, cell to chassis, and that changes how the modules and the pack itself are designed, which are really important for lightweighting as well, and even some safety aspects, to make sure thermal propagation is addressed. So I think they're all very important, but the most game changer really is kind of a chemistry approach.
Mm-hmm. So would you say then the enclosure, how we do bus bars, how we connect it, maybe even a BMS is almost like a commodity now?
Some of that might be a commodity, yeah. I think there's definitely room for changes within the enclosure and how the cells are integrated into the pack or the vehicle. There's new approaches now occurring, like I said, with the cell to pack, which I think are starting to be some novel concepts coming out. But yeah, the bus bars and the harnesses and the BMS, they're getting more closer to a commodity, in my opinion.
Mm-hmm. Okay. Would you also then say that wireless BMS is like the future? Because a big hype is right now about wireless BMS everywhere. Is this really that unique? Is it really that of a game changer? Is it a weight reduction, wiring reduction, cost reduction, or?
It's definitely a step towards some lightweighting there, I think. It is a new technology that I think is an important to look at. It does allow for you to reduce some of the components from the harness standpoint. Today, maybe the cost is a little bit higher, and ultimately, as it does get commoditized, it could have some further cost reduction. But it is a technology that I think helps continue to simplify battery systems and have maybe some weight reduction, and also improvement in manufacturing and serviceability as well there. Because you don't have to manage the connections to the sensors for voltage and temperature and things like that.
A lot of investment goes into battery technology, and mainly I think right now, at least for future investments, future technology, solid state, right? In your opinion, how far away are we from having solid state batteries in mass-produced electric vehicles? Because they're there today, right? They exist today. We can see that people, have put them into a car, drive around, say they're great. Then I hear constantly, there's still an issue. How we cool them and how we produce them. We're still years and years away. So interested in your opinion on that.
I would say probably 5 to 10 years for mass production. They're available today. I think they'll first become more popular in the consumer electronics market. But then as they continue to refine the technology and get the life that is needed for the automotive applications, as well as the size, just to have that large amount of energy, kilowatt hour, coming from that technology, we're probably somewhere 5 to 10 years away.
Okay.
I hope sooner than later.
Something new, exciting for you to work on.
I think that will be a big game changer when that does come to fruition.
In regards to safety, in regards to power density, in regards to what
definitely
specifically?
Safety. In general, solid-state battery cell technology is really a kind of a game changer there in terms of like thermal propagation and thermal events that can occur with some abuse conditions of other cells. So that is really an important factor, because then you can remove some of the other aspects of a battery that you need to have to control and protect some of the chemistries today to keep them safe. And so with that, the complexity might go down from the overall battery system, and just in general, the weight as well can have reduction there too.
Do you see the manufacturing, the actual cell manufacturing, being simpler as well than liquid?
Sure.
Yeah.
With just general concept of no more electrolyte, or the electrolyte is a solid component. That's a much more manageable aspect of cell manufacturing there. So that definitely would be a simplified aspect.
If I put you on the spot and ask for a guess, today they say about $100 to $120 per kilowatt hour right now, right? Is a battery, the cost of a battery.
Yep.
What would you say, let's say in 5 years, the solid state would be at? If you had to guess, is it half because the manufacturing is simpler and let's say we have the same volume as liquid batteries?
I don't think it's half.
Okay.
I would say, I don't know, maybe 2/3 to 3/4.
Okay.
And that is just
I
quite
guess.
an estimate on my part.
Yeah. Be a little provocative here. Going back to BMS, we mentioned before BMS. I see from a lot of customers that are coming to us, they're asking for BMS, right? And a lot of OEMs, at least, in many cases, want to keep BMS development in-house. Is it a tremendous or a moderate battery technology differentiator, in your opinion, ultimately for a battery pack or for an OEM?
The hardware itself is pretty general, same, across the board. I mean, you have to be able to monitor the cell, control the battery system, and report out to the vehicle. But the integration and the software, the systems development is what is the differentiator. Different chemistries require different algorithms, and those algorithms need to be proven out and verified and validated. That is the differentiator. The hardware, it has a lot of similarities kind of across the board. As long as the voltage range and the current range are understood and known, it's really more the integration that is the differentiator, in my opinion.
Okay, so it's the software guys again that have the advantage here versus us hardware guys.
Yep.
All right. What do you see as the most important technology to advance battery performance? I know you said cells, so let's for a moment leave the cells out. Besides the cell, what is it? Is it the simulation? Is it the BMS? Is it the software? Is it the integration? Is it how we make the vehicle more efficient? So is it an e-motor and an inverter and all these things? How do we advance the battery's performance? Again, cell for a moment left aside.
The main performance, I think, that you need from an overall system is really the range and the energy that is needed to propel the vehicle, and so different aspects of being able to lightweight or having more efficiencies, within the inverter, the motor, things like that really allow the system to be as most efficient as possible is probably a large, or at least the next aspect that would be helpful beyond the continued maturation of cell chemistry and new chemistries coming out that help to propel that.
Okay. I know you lead a lot of battery development for us amongst other projects. How critical is simulation? How critical are our simulation tools that we have or tools we use from third parties? How critical is this today? Absolutely critical.
I think with the simulation technology that we have at AVL and what we do is really important in order to go fast, as well as do the first doing virtual verification so that you can look at the system and see what your expectations are for that chemistry in an abuse condition, that in order to control the cell and keep the cell safe, thermal management, different safety features that can be simulated to make sure that the battery is under control, life, all of that is really in simulation is really quite important, and it allows you to kind of hone the product in before you're actually making physical parts. Furthermore, you can even do some reduction of validation potentially. You can hone in your testing to using simulation so that you're testing it right the first time, and you're really focusing on what you're trying to test. All that activity can help to shorten the overall product development life time frame, and so simulation, all that aspect is really important, and it also goes into the SOX development too, the state of charge, state of health, state of power, state of function. I mean, you need that simulation to get those type of functions developed for modeling and verification.
Okay. Again, leaving battery cells out, so it's not an option as an answer, because I know that is definitely one of them. But if you look at from 5 or 10 years ago, you've been in this space for a very long time when it comes to batteries. What has really changed, again, outside of the cell technology from, let's say, 10 years ago to today?
I think from the market standpoint, I think there's a growing interest really in electrified vehicles. I think they're actually now being more adapted or accepted by the consumer base, which is quite a game changer, because then OEMs will focus more of their portfolio to have that. I think there's also some new technologies coming on the market from inverters and other aspects, higher power capability at the other components, the inverters, the motors, and things like that, just to really make the system more efficient and have a powerful, fun to drive vehicle.
So it's really what you're saying is it's kind of a big difference. Again, outside of the cells, I assume, is the system view and how we integrate the system much more efficient and effective, maybe then.
Absolutely. I mean, it is it is always a system, right? And just because you have a more powerful battery doesn't necessarily mean you're going to get all the gains that come with that, right? You have to have the right the components all have to be sized appropriately so that you get the best performance that you're focusing on, whether it be range or actual performance vehicle, like a racing type application.
Biggest secret that maybe few people know about batteries, and don't share any AVL technology secrets, which we certainly have, but biggest secrets are maybe an area of a battery, again, thermal, cooling, structural, BMS, cell, whatever, that you feel few people focus enough on, let's put it that way, that are very critical. I know everything is critical, obviously, but from your perspective and your experience, again, your entire experience, and now with AVL being the segment lead for electrification, which includes batteries, what's the one thing you sometimes feel like customers will pay more attention to when it comes to a battery? Maybe that they think this is, it's an obvious one, but you say it's really not an obvious one. It's really not a given. It's not a commodity.
It's a good question. I think there's a couple things that come to mind. I mean, sometimes some situations, thermal management is kind of considered just a general commodity or something that you must have with a battery, but
just do it kind of thing.
Just do it.
Yeah, just do it. It's not a big deal. Do it. Yeah.
But if you can improve your thermal management system, to keep the system cool, you can run it harder and get some more life, more power out of it, as well as if you have a generally stable overall system thermally, that's also helps to get longevity out of it too.
Yeah, okay.
I mean, I'm sure there's other aspects that are not coming to mind right now, but
yeah, it's a good one. I know you joined us 2 years ago?
About a year and a half.
A year and a half ago, I stretched it out to 2 years ago. When it comes to your engineering work that you're still doing today, your job has changed, obviously. But what are the biggest differences of what you've done 3 years ago that you're doing now? Not including more video calls because of COVID and working from home. What's the biggest difference that you're doing now or that you're able to do now that you weren't able to do 3 years ago?
Well, 3 years ago I wasn't at AVL, and I was definitely more battery focused. So now being at AVL, that really allows me to look at different technologies and components in the overall system of an electrified vehicle. Looking at inverters and motor controllers, e-axles, things like that, as well as the testing of all those components. It really has, allowed me to get a broader sense of what really goes into a vehicle electrification, and gain that knowledge and that just the expertise, and continue to see new things that I, maybe 3 years ago, I wouldn't have had the opportunity to see that because I was more, focused in on just the battery systems, which I really, really enjoy, actually. So that's been a great change.
Good. So maybe last question, one thing that you could tell, if you could tell your customers to be more clear about, to be more detailed about, to be more whatever it might be in your daily job. It might be, again, thermal propagation. Give me more specifications on what your requirements are there, or pay more attention to this, or give me more details on how you would like me to test the battery instead of just, I expect you to test the battery once you're done. What's the one thing you would like to tell the customers when it comes to the responsibilities that you have, that if you could make them or ask them to do better, what would it be?
I think one of the things that I think is overlooked is what is the end game, right? So a lot of times engineers, including myself, like to get really focused in on specific details. But sometimes you have to step back and look at the overall picture and see what is the end goal. And what we're doing today and what we're working on, that we're laser focusing on, does that really get us to the end game and the ultimate goal of the product or the vehicle or whatever the focus may be. And sometimes you have to recenter yourself to kind of do that. And I think that's everyone, or maybe it's just a general human nature. Sure. But sometimes that alignment with customers is good to kind of do a reset, and it maybe doesn't happen as often as it should. Very good.
All right. Thank you, Adam, for your time. This was it again for this episode. Hope you appreciate it, and certainly lots of great knowledge and insight from Adam here. Thank you.
Thank you.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.